Good morning, class. I'm just showing you how to factorize a quadratic. By the way, just a recap, what is a quadratic? A quadratic is an algebra or algebraic expression where the maximum or highest power on the variable, that's the variable, is 2. In fact, if you look carefully, the power on this x is 2. There is a power on this x is actually 1. And this is a non-x term, also known as a constant. So these are terms. That's the x squared term, that's the x term, and that's the constant. So when the highest power is 2, it's called a quadratic. If the highest power was 3, it's called a cubic. If it was something like that, where the highest power effectively is 1, the 1 is invisible on the power as well, it's called a linear expression. Of course, if it's an equal signs to 0 or something, it's an equation. Now, how do we factorize this? So we looked at this yesterday. What I told you guys was to build up two brackets. Okay, here we go. Control C. I'm just going to. So I said build up two brackets. Okay, sort of a template for you if you want to call it that. And inside the bracket, put an X here and put an X. Now, that's the key. The last number is a positive. You got to think of two numbers or the factors of 12, a pair of factors of 12. The factors of 12 are 1 and 12. Both positive will multiply to give you a positive 12, or both could be negative, isn't it? Negative 1 times negative 12. You could also have 2 and 6, 3 and 4. So it pays to list them down. For example, 1 times 12, you can have 2 times 6. Very soon you don't need to do this part because after a lot of practice you'll be really good. Now we're looking for a pair of factors in such a combination that they should sum to give that coefficient there. Now, there's two possibilities, either both positives like this, or you can have them both negative as well. So I'm just going to copy it. It's this there. Of course, change them to negative. So that's 2, 6, and this is 3, 4. So positive 12 can be obtained by doing that, or that, or this, or that, and so and so. Now we're looking for, so effectively there's 1, 2, 3, 4, 5, 6 combinations to get a multiplication or a result or a product of positive 12. We're looking for the perfect combination which will sum to give positive 8. Now, positive 8 cannot be obtained with two negative numbers because these two numbers will sum to give me negative 13. So delete, don't want that. These two numbers will sum to give me negative 8 because negative 2 plus negative 6 is effectively negative 2 take away 6, which is negative 8. So no. Negative 3 and negative 4 will give me negative 7. So no. So it's got to be both positives. Of course, the perfect combination is this. It's pretty obvious because 2 plus 6 is 8. So both positive. So I'm just going to put down plus 2 plus 6. There we go. Now, why have I put x plus 2 first? It doesn't matter actually. If you wanted, you could put that bracket in the end. It does not matter because multiplication order doesn't matter. Now you can check using the, I called it the claw method. So you can go x times x, which should effectively give you x squared. We'll copy the x squared from here. I'll do the expanding for you just to show the answer. So x squared, and then take this x and you multiply with the 2, which will be a positive 2x or a plus 2x. That positive 6 times that is plus 6x, and the 6 times 2 is plus 12. Now that's a quadratic term, a power of 2. So that's on its own. It doesn't have any other like term, so I don't have to deal with that. Can I highlight this? I would like to highlight that just to show that, okay, I don't need to deal with it. Okay, I'll just put that in green. Now, this two thingy-majig is in the middle. They're like terms, which means I can add them. So what is 2x plus 6x? 2 apples plus 6 apples. $2 plus $6, like terms, giving me 8x. So far I've got my x squared and my 8x. So these two things will give me 8x effectively. And the plus 12. So there are three terms now. The power of 2, the power of 1 over here, which is invisible. If you want, I can add in that, but nope. In math, we tend not to put the power of 1. It's kind of conventional. And the positive 12. So that's the factorized version. This is the expanded version, just so that I could check if my factorization was correct. So that's how actually you factorize. So you don't need to go and expand it, but if you wanted to check your answer, you could. I've done a few more here. So what about this one? We've got a negative result in the end. So 1 times 21, no, 2, 3 times 7. I'm sure that's all the combinations of pairs of factors I can get to get a result of 21. Now, two brackets again, x's go in the front. Now, be careful. We want a result of negative 21, dependent that sum should be positive 4. Right, so 1 and 21 will not have a difference of 4 ever. So no, definitely not. 3 and 7 will have a difference of 4, but we got to be careful where the negative sign goes. Because to obtain negative 21, one of them has to be positive, the other one has to be negative. Now, if I put a negative sign there, what's 3 times negative 7? Negative 21, smiley face, we get it. 3 take away 7. Oh, it's not positive 4, it's negative 4, which means the negative sign should really be over there. So factorization is complete. We got x take away 3 and x plus 7. Of course, the brackets could be in any order, so it doesn't matter. I could have it like this, or I could say, or I could have it the other way around. Yeah, both of them mean the same thing, okay? So doesn't matter whichever bracket you want to put first, either this or that. Nice and easy. Now what do we do with two negatives? Same thing, factors of 15, 1 times 15, 3 times 5. Which two numbers will have a difference? Now, why am I saying difference? Because it's a negative number. Difference of negative 2. Negative 2 means the larger number has to be small. So there, 3 take away 5 will be negative 2. Definitely not that, and I'm sure that should make it easy. So all I got to do is go x plus 3 and x minus 5. Once again, brackets in any order. Okay. Last one with positive. So this one's a positive. However, that one's a negative. So it potentially could be 1 times that, 3 times 9. I'm pretty sure those are all the factors of 27. How do we, oh, actually, I did intend that to be a 6, actually. How do we get a difference? Oops, I mucked up. That was a minus 12, folks. My apologies. That's negative 12. So how do we actually get negative 12 using either that or that? See, 1 and 27 will sum to give me 28 or have a difference of 26. So definitely not. Now, 9 and 3 sounds a good candidate for us because 3 and 9 will have a sum of 12. Now, I know you're thinking how to get negative 12, so hold on. And have a difference of 6. So what if we put a negative there and a negative there? What's negative 3 times negative 9? Positive 27. And also negative 3, add a negative 9, it goes even lower, so it's negative 12. Bingo. So that's our factorization. X take away 3 and x take away 9. All right, I hope that all makes sense to you, and you can continue with your factorization worksheet. Thank you.